There are two parts to the mill. The first part that I'll talk about is the head. The head consists of the spindle forward reverse switch, the e-stop button, the RPM adjustment dial and readout, the gold box on the left side is the power drawbar in and out buttons. Next is the digital scale, the quill handle and lock. And over to the right is the Axis DRO control panel. The second part is the table and the knee. That part consists of the Z power feed and hand wheel, the Y-axis hand wheel, the table, which the vise is mounted to, and the X-axis hand wheel.
Open the bottom drawer using the notch on the side. All the tools you'll be using are in this drawer, so leave it open.
Familiarize yourself with the hand wheels on the mill before you start machining. The X-axis hand wheel is located on the right side of the table. Extend the handle on the hand wheel and turn the wheel in both directions. Notice the number changing in the X on the DRO when turning the hand wheel. The Y-axis hand wheel is located on the front of the machine. Do the same with the Y-axis hand wheel as you did with the X. The Z-axis gearbox is located to the left of the Y hand wheel. It has a power feed option to go along with the hand wheel. Using the power feed saves time when moving the table up and down. To raise the table, lift up on the lever on the left side of the gearbox. Notice the number getting smaller in the Z on the DRO. To stop the feed, put the lever back in the middle where it started. To lower the table, push the lever down. Notice that the numbers are getting larger in the Z on the DRO. The Z hand wheel is generally used to make finer adjustments, such as setting the tool to the part, as you will see later in the video. Let's transition over to the DRO itself. The buttons on the DRO that you will be using are the X, Y, and Z, the numbers, and ABS set. Please do not use the arrows just to the right of the screen. The video identifies these arrows with a red box with a line through the middle of it. If you accidentally press one of the arrows and a green box appears on the screen, please notify staff. We will get you back into the proper screen. Failure to do so could result in damage to the part, the tool, and the machine, or all the above. Before placing the part in the vise, clean the jaws of the vise with a rag. When finished with the rag, place it in the toolbox. Do not leave the rags on the machines. Take the parallel and place it inside the jaws of the vise. Now place your part on top of the parallel as shown, with the boss to your left. Leave approximately 1/4 inch of the part sticking out of the right side of the vise for measuring. Secure the part in the vise by turning the vise handle clockwise until the jaws are tight against the part. Tighten the handle firmly. Check the parallel under the part to see if it is loose. If it is, grab the dead blow hammer and firmly tap the part until the parallel is tight. This will ensure that the flat being created will be parallel and not tapered.
Before loading any tools into the spindle, ensure the quill is all the way up and the quill is locked. Locate the collet into the spindle by lining up the keyway on the collet with the key in the spindle. Place the end mill into the collet, holding at the bottom of the shank with your index finger and thumb on your right hand. Hold the collet up when holding the end mill in place. To the left side of the mill head is a gold-colored box with 2 buttons, labeled in and out. Firmly press and hold the in button. When pushed all the way in, the in button should almost be flush with the gold plate. This will activate the power drawbar to tighten the tool in the spindle. Be aware that the tool will rotate when the drawbar tightens the tool.
Adjust the quill stop by turning the stop on the threaded rod up or down. It also has a quick release button to bypass the threads. Set the stop at least an inch or so from the top. Unlock the quill, bring the quill down to the stop, and lock it again. Now turn on the digital scale and zero it. Turn the spindle on by turning the switch to the forward position. Adjust the RPM dial until the readout reads 1000 RPMs. Turn the Z hand wheel clockwise to raise the table. Raise the table until the tool lightly touches off on the top of the part. Once the tool is touching the part, use the X hand wheel to move the part away from the tool. Press the Z on the DRO and type in the diameter of the part. In this case, I'll enter 1.0 and press Abset. Add cutting oil to the part and turn on the spindle. Raise the table until the DRO reads 0.980 in the Z axis. Note, please do not take more than 30,000 depth of cut at one time. Use the X hand wheel to slowly feed the part all the way across the end mill. Note, the slower the feed rate, the better the finish will be on your part. Move the part away from the end mill and shut off the spindle. Use a rag to wipe away any chips left on the part and remove the rag from the machine. Now take your caliper and measure from the flat you just milled to the bottom of the part. Compare that number to the number in the Z on the DRO. If that number is off by more than 2 thousandths, change the DRO to the number you measured with the caliper. Now raise the table with the Z hand wheel until the Z reads 0.950. Remember, no more than 30 thousandths depth of cut at one time. Add cutting oil and turn on the spindle. Use the X hand wheel to feed the material across the end mill. Move the part away from the end mill and shut off the spindle. Wipe the part clean with a rag and remove the rag from the machine. Measure the flat and compare it to the number on the DRO to see if you are still on track. If all is good, add cutting oil and turn on the spindle. Use the Z hand wheel to move the table up until the DRO reads 0.938, which is the finished dimension on your print. Repeat the milling process as stated earlier using the X hand wheel. This is your finished pass, so use a slower feed rate to create a good finish on the flat. Once the first pass is complete, feed the X-axis in the other direction. Move the part completely away from the end mill and shut off the spindle. Use a rag to wipe the part free of chips and remove the rag from the machine when finished. Now measure with the caliper. The print calls for a dimension of 0.938 with a tolerance of plus or minus 0.01, which means if your measurement falls between 0.928 and 0.948, you are good. Lower the table with the Z hand wheel until the DRO is at 1 inch in the Z axis. Remove the part from the vise. Clean the vise, parallel, and part with a rag. Place the parallel back inside the vise and place the part on top of the parallel with the milled flat up against the solid jaw as shown. Leave approximately a 1/4 inch of stock sticking out of the right side of the vise for measuring and milling to length later. Secure the part in the vise and use the dead blow hammer to firmly tap the part until the parallel is tight underneath the part. Since the DRO should be set fairly close from the first flat, bring the Z up no more than 30,000 steps the cut at a time. In this case, I'll bring the Z up until the DRO is at 0.970. Remember, add cutting oil to the part for each cut. Turn on the spindle and use the X hand wheel to slowly feed the part all the way across the end mill as you did with the other flat. Move the part away from the tool and shut off the spindle. Use a rag to wipe away any chips left on the part and remove the rag from the machine. Use your caliper and measure from the flat you just milled to the bottom of the part. Compare that number to the number in the Z on the DRO. If that number is off, change the DRO to the number you measured with the caliper. Raise the table with the Z hand wheel until the DRO reads 0.938. Add cutting oil and repeat the milling process as stated earlier using the X hand wheel. Use a rag to wipe away any chips left on the part. Use your caliper and measure from the flat you just milled to the bottom of the part. Compare that number to the number in the Z on the DRO. If that number is off, change the DRO to the number you measured with the caliper. For the finish pass, raise the table with the Z hand wheel until the DRO reads 0.938. This is the finished dimension on your print. Add cutting oil and repeat the milling process as stated earlier using the X hand wheel. This is your finished pass, so use a slower feed rate to create a good finish on the flat. Move the part completely away from the end mill and shut off the spindle. Use a rag to wipe the part free of chips and remove the rag from the machine when finished. Measure with your caliper. Your print calls for a dimension of 0.938 with a tolerance of plus or minus 0.01. If your measurement falls between 0.928 and 0.948, you are good. Lower the quill stop so the tool is below the bottom of the part when the quill is extended. Lower the quill so the side of the end mill will touch the end of the stock. Lock the quill. Turn on the spindle and leave the RPM set at 1000. Use the X hand wheel to slowly move the part towards the end mill until the end mill lightly touches the part. Now move the part away from the end mill by rotating the Y-axis hand wheel counterclockwise. This will bring the table towards you and the end mill away from you. This puts the end mill in the climb milling position, which I will explain later. Shut off the spindle. Now move the part away from the end mill by rotating the Y-axis hand wheel counterclockwise. And measure the length of your part and enter that number into the DRO in the X-axis. Add cutting fluid to the part and turn on the spindle. Use the X hand wheel to adjust your depth of cut. No more than 30,000 steps the cut at one time. Slowly turn the Y hand wheel clockwise to remove the material from the end of the part with the end mill using the climb milling method. Climb milling is when the direction of the feed is going with the rotation of the tool and is the preferred method when using the side of the end mill. Once the tool is all the way across the end of the part, turn the Y hand wheel counterclockwise to get the end mill in the climb milling position again. Shut off the spindle. Now measure the length of your part with your caliper. Compare the caliper with the dimension on the X and the DRO. If that number is off, change the DRO to the number you measured with the caliper. Add cutting oil to the part and continue milling the part to length using the climb milling method. As I stated earlier, no more than 30,000 step the cut for each pass. If you have questions about climb milling versus conventional milling, please see staff. We'll be happy to answer your question. Periodically shut off the spindle and measure the length to make sure the DRO and the caliper are consistent. If you need to adjust the DRO, now is the time to do it. Continue climb milling until you reach your finished length. In this case, our finished length is 3.125 for the alpha part. After your final pass, shut off the spindle and measure the length to be sure it's within tolerance.
If the measurement is within the tolerance, raise the quill and lock it in place. Lower the table. Lower the table to give yourself plenty of room for the keyless chuck, the drill, and the tap. You should not need to raise the table after this step. Once you have about 6 inches of space, stop the table. Make sure the quill is all the way up and locked. With a rag in your hand, hold it below the end mill and firmly press the out button until the end mill drops into the rag. When pushed all the way in, the button should almost be flush with the gold plate. Load the keyless chuck by lining it in the spindle and firmly pressing and holding the in button. When pushed all the way in, the button should almost be flush with the gold plate. Now tighten the edge finder into the keyless chuck as shown. Next, lower the quill stop to give yourself enough room. Turn on the spindle and turn the RPM adjustment dial down until the readout is approximately 800 RPMs. We will first be finding the 0 in the x-axis. Bring the quill down so the spring portion of the edge finder is alongside the end of the part, as shown. The edge finder should be running out at the bottom. While looking down the x-axis, slowly move the X hand wheel so the part makes contact with the edge finder. Keep making small adjustments to the X hand wheel until the runout of the edge finder gets smaller and smaller and slightly breaks the other way. Raise the quill so the edge finder is above the part. Zero the X on the DRO. Now move the edge you just found to the center of the spindle by the radius of the edge finder, which means you should move the X hand wheel until the X DRO reads -0.25. Visually, look to see if the edge of the part is in the center of the spindle. If so, zero the X axis on the DRO. You just found the X origin. Now, we need to find the 0 in the Y axis. We will be finding the edge of the back solid jaw that the flat is up against. Bring the quill down so the edge finder is inside the solid jaw. While looking down the Y-axis, slowly move the Y hand wheel so the solid jaw makes contact with the edge finder. Keep making small adjustments to the Y hand wheel until the runout of the edge finder gets smaller and smaller and slightly breaks the other way. Raise the quill so the edge finder is above the vise. Zero the Y on the DRO. Now compensate for the radius of the edge finder. In this case, the Y value should read 0.25. Visually look to see if the edge of the solid jaw is in the center of the spindle. If so, zero the Y-axis in the DRO. You just found the Y origin. Take the edge finder out of the keyless chuck.
Load the spot drill into the keyless chuck. Bring the spot drill down till it touches the top of the part. And zero the quill readout. Turn on the spindle and adjust the speed to 1000 RPM. Use the spot drill to a depth of 50 thousandths of an inch. Now remove the spot drill and put it back in the toolbox. Grab the number 7 drill and load it into the chuck. Touch the drill to where you just spot drilled and zero the quill readout. Add some oil before drilling. With an up and down motion, peck drill the part until you reach -0.7. Remove the drill and put it back in the toolbox. Grab the countersink and load it into the chuck. For the countersink, lower the RPM to about 300. Use the countersink to create a chamfer around the hole. Remove the countersink and put it back in the toolbox.
Place the square end of the tap into the tap handle with the corners locating into the V-jaws. Now tighten by turning the collar on the tap handle as you would a keyless chuck. Take the dead center and mount it into the keyless chuck. You may have to lower the table to make room for the tap and tap handle. To lower the table, place the Z power feed lever in the down position until there's room to accommodate the tap and tap handle. Once the table is in position, place the lead of the tap into the hole and move the quill down to line the dead center with the drilled center on the tap handle. Add cutting fluid to the tap. Keep light pressure on the quill handle when tapping. Do 3 half turns clockwise to create threads and 1 half turn counterclockwise to break the chip. Remember, retract the quill slightly when breaking the chip. This will allow room for the tap to move back. Repeat the 3 half turns clockwise and 1 half turn counterclockwise until the tap reaches the bottom of the hole. You will know when the tap is at the bottom. It will be harder to turn. Do not go any further at that point, otherwise you could break the tap. Once you've reached the bottom, retract the quill and remove the tap. Notice the chips in the flutes of the tap. These will need to be removed before using the tap again. Place a rag over the hole and blow the chips out using the air blast located at the machine. Now check the thread depth. If the nut on the thread gauge bottoms out on the flat of your part, the depth is good. In this case, the threads need to be deeper. There might have been chips at the bottom of the hole when tapping the first time. That would prevent the tap from going all the way to the bottom. So to fix this, run the tap back into the hole and try to create a couple more threads. Add cutting fluid and repeat the tapping process until you feel you reach the bottom of the hole. Remember, use the 3 half turns clockwise and 1 half turn counterclockwise method. Once you've reached the bottom, retract the quill and remove the tap. Use a rag to cover the hole and blow the chips out using the air blast located at the machine. Now check with the thread gauge again. Make sure the nut on the thread gauge is seated on the flat of the part.
Using the file in the forward direction, remove any sharp edges from your part.
Use the part drawing to clean the jaws of the caliper. Zero the caliper. Notice, the part drawing has specified default tolerance in the title block, so all of your measurements should be plus or minus 10th of the specified dimensions. If your measurements are not within the desired tolerance, keep measuring. A staff member will later determine if you should fix, modify, or redo the part. Measure the length of the part. Your measurement should be between 3.115 and 3.135. Make sure to record your measurements on the part drawing. Measure and record the size of both flats. Your measurements should be between 0.928 and 0.948. Measure and record the diameter of the boss. It should be between 0.74 and 0.76. Using the caliper's depth rod, measure the boss length. When measuring, ensure the caliper end is parallel to the boss face and the depth rod is parallel to the boss's cylindrical surface. It should be somewhere between 0.74 and 0.76. Record your measurement. The final horizontal hole location should be within 2.115 and 2.135. To accurately measure this distance, you must take a total of 2 measurements. Do not eyeball the center of the hole or you will get an inaccurate measurement. First, measure the distance from the back of the part to the edge of the hole. Write your measurement down. Next, use the inside jaws of the caliper to measure the diameter of the hole and write the radius down, or half the diameter. So, if you get 2.025 for the first measurement and 0.1 for the radius, your final measurement will be 2.125. Grab the parallel. Zero the caliper on the thickness of the parallel. With the parallel and part in one hand, measure the distance from the flat of the parallel to the edge of the hole. Use the same procedure as before to find your final measurement. This measurement should be within 0.428 and 0.448. Remove any tooling from the spindle if you haven't already done so. Please note, you should not use an air hose to clean the machine. There is a risk of airborne debris injuring someone. Remove and clean any tooling in the vise straws and use the rag to wipe the vise down. Use the chip brush to clean the sides of the vise. Remove the aluminum table covers and dispose of the chips in the metal recycling bin. Clean the rear way cover. Move the table all the way back and clean the forward way cover. Center the vise on the spindle and leave the vise slightly open. Shake out the mat. Sweep the bottom of the mill and make sure to clean out any excess oil. Sweep the mill surroundings. Place the mat back. Ask a staff member to check off your machine. You're all done cleaning. Please ask one of the professional staff members to grade your part, or if it's after hours, please create an appointment using the QR code on the screen or the link in the description.